Hello again. We're back for more on probability, and instead of mutually exclusive and addition, this one is on independent events and multiplication rule. So we're talking about events and whether or not they're independent, and then the multiplication rule is how we deal with probabilities when we're asked whether something and another something will happen. So let's move into it. Independent events are two events that if the occurrence of one event has no effect on the probability of other, then they are independent. So for example, when a coin is tossed twice, so landing on heads the first toss and then landing on tails the second toss. These are my events, and I want to talk about what is the likelihood, or are they impacted by each other? And if it's a fair coin, meaning that it's an equal chance for heads, equal chance for tails, there really is no influence on that second toss, whether you got a heads or tails on the first toss, despite what you may kind of feel or think. In mathematics, those are considered independent events because the second flip does not depend on the first flip. And so first, when you're dealing with when you're dealing with a situation with something and another, it helps to determine if these events are independent. So let's just talk about some examples of independent events. One is you're on an online class and it's also sunny outside. Yes, unfortunate, but it's not dependent. So this wasn't the fault of the online class to keep you inside. If you pick a card from a deck, then replace it, then pick another card. The fact that you replace it means that every time you pull a card and replace it, there's really a completely different opportunity for you to get a different card. So there's no influence from that prior pick. When you toss a coin and roll a dice at the same time, they don't impact the other. There's no outcome that would be influenced by whether the coin lands on heads. Does not change how the dice will be rolled when they're tossed at the same time. Examples of dependent events. So these things do have an influence on one another. When you're playing Spotify, the next song that comes up, if it's based on your listening history, is going to be dependent upon that listening history. And then if you pick a card from a deck and then pick another, so the fact that you pick a card removes one of the options from that second pick. And so as you continue to pick cards, there's going to be fewer and fewer options. So they are dependent on those prior picks. So the multiplication rule is when we're dealing with probability questions and they ask, is one event and another going to occur? What's the likelihood? What's the probability? So if asked whether one event and another will occur, first determine if it's independent. That will help us to determine what kind of multiplication rule will apply. And in this slideshow, in this video, we're only going to deal with events that are independent. Conditional probability will come up later. But I did want to introduce you to both the independent and dependent formulas. So with independent events, the likelihood of both A and B, remember that's our intersection sign, both A and B, the probability is the probability of A times the probability of B. Now with dependent events, it looks very similar besides one thing. So here the probability of A and B is the probability of A times the probability of B given A. So this would be like A is the second event. If A had happened, that would influence what probability of B is. And this is going to be a different formula. We'll look at this later. But this is when it's dependent. So this is going to be something we'll deal with in conditional probability. I just want to introduce it to you. Because if you think about it, the probability of B given A in an independent event is just B. It's like tossing that second coin. If the probability of getting tails the second toss, given that heads occurred, doesn't change anything. So it's kind of the same formula except for this P, this probability of B given A is just probability of B. So the other thing about this formula is a lot of times they'll ask, are these two things independent, given that both is this probability, the one is this probability and the other is that probability. They'll give you the three numbers, and then if you can multiply the probability of A and B and end up with the probability of both, then you've proven that they're independent events. So let's look at an example. What is the probability of rolling a 3 on a dice, so landing a 3 when you roll it, and landing heads on a coin? So we have a dice over here and a coin over there. So they're not really dependent, are they? They're independent events. Rolling a 3 is event A, landing on heads is event B. So we'll deal with the probability of A, which is that one outcome is 3 out of the 6 types of outcomes we can have for a dice. Now the probability of landing on heads with a coin, there's only 2 outcomes with a coin, heads or tails. There's only 2 sides. So one of those sides is head over the 2 outcomes. So this is the probability of A, and that's the probability of B. And this question asks, what is the probability of both and happening? So A and B is equal to the probability of A times the probability of B. So that's the 1/6 times 1/2, which is, remember, we multiply the numerators and denominators. So 1 times 1 is 1, 6 times 2 is 12. That's our fractions when multiplying. And I've given you the decimal in case you did this in your calculator and you just want to confirm. So since this question is asking about one thing and another occurring, we multiply the independent events. So this is our and. Remember, the addition rule was or. When it's or, you add. When it's and, you multiply. Because it's less likely to occur that 2 things would happen, so it's going to be a less chance of both happening. Here's another example. What is the probability of rolling an odd on the first roll and an even on the second roll? So our events, rolling an odd and rolling an even. They're independent because as soon as you grab that dice off the ground, you've just rolled it, it's a new fresh roll. There's no chance of being influenced from that first roll. So we look at the probability of rolling an odd. We have 1, 3, and 5 are our 3 options out of the 6 total outcomes for rolling a dice. And then the probability of B, which is the 2, 4, 6 are even numbers out of the 6 total outcomes for rolling a dice. And I've reduced the fraction just to make it simpler. So we'll go back to our independent multiplication rule formula, which says the probability of A and B is equal to the probability of A times the probability of B. Simply put, I have 1/2 times 1/2. And that's 1/4 because I multiply the numerators, multiply the denominators. That becomes my new numerator and denominator, or 0.25 if you like decimal. Okay, last thing is when they've given you one event type, but they're asking you if that event happens multiple times. So the same event, but it's happening multiple times. So here the chances of a light bulb burning out in a year is 30%. What's the probability of 2 light bulbs burning out in a year? So there's really not like 2 events, but what we're saying is there's 1 light bulb and a second light bulb, and they have the same probability applied to them. So we're going to call the events the first light bulb burning out and the second light bulb burning out. And they could burn out at the same time. It's not really like a one before the other. They're just at some point during that year, will we have 2 light bulbs burning out? And what's the probability of that? So we have probability of A, which is the 30%, or 0.3. Remember, 30 divided by 100 is my decimal. The probability of the second light bulb burning out is the same. It's just the same thing happening. A light bulb burns out with a 30% chance every time. Now we want to know what's the probability of 2 light bulbs burning out, both happening. So the probability of both A and B is equal to the probability of A times the probability of B. Simply 0.3 times 0.3, which is 0.09. So remember, please type this in your calculator if you don't. Remember, if you're multiplying decimals, you're going to have to carry that decimal place an extra step. Because we don't want 0.9, it's not a 90% chance. It's actually lower to have 2 light bulbs go out if it's 0.3 and 0.3 for just one at a time. Okay, there you have it.